Hello and welcome to Symmetry. Please make sure you have page 32 in front of you. We're going to look at this together. The first thing says lines of symmetry, where we can cut an object in half. This first one is relatively straightforward and easy. If I was to look at this isosceles triangle, a line of symmetry would definitely be up and down the triangle right here because they are mirror images on each side. There are no other lines of symmetry on that one. In this rectangle, a line of symmetry would definitely be, in this case, horizontal. So we would have a horizontal line of symmetry, and we would also have technically a vertical line of symmetry. So if you look at both of those, the objects are the same on the right and left, as well as the top and the bottom. And then with this shape here, this is a hexagon, we have many different lines of symmetry. The first one being that it connected these 2 points. We could also connect this way. We have a horizontal line of symmetry here. We also have a vertical line of symmetry here. And technically, we could have diagonal lines of symmetry here as well. So there's a lot of different lines of symmetry in this case. And you'll notice that the regular hexagon actually looks like it falls upon itself rather often. The next one, this looks to be as though it was a parallelogram. And a lot of times people think that this is a line of symmetry, but if you think about it, this point doesn't really have anything to match up with on the bottom. It would be in the wrong spot. Other people think that we have vertical lines of symmetry, and technically that's also incorrect, so that's not going to work. And ultimately, other people think that it has what we call a diagonal line of symmetry going this way. And that doesn't work either. So technically, a parallelogram doesn't have any lines of symmetry. Let's take a look at the next one. So on the bottom half of this page, it talks about rotational symmetry, and this is rather interesting. We're talking about taking these particular shapes, either an equilateral triangle or a square or a regular pentagon or a hexagon, and actually rotating them. So let's fill this in first. There are definitely 3 sides here. There are 4 here, 5 and 6 there. And now what we're going to do is take a look at what happens when I rotate them. So looking at this triangle, when I look at this triangle, I technically have to rotate it 1/3 of a turn in order to get the triangle back. I'll do it again. So I'm going to rotate this triangle 1/3 of the way around, and it creates the triangle again. So back to this page, the angle of rotation would be 1/3 of a circle, or 360 divided by 3, which is 120 degrees. Looking at the next shape, I have a square. So if I took this square and I rotated it basically 1/4 of a turn, then I would have a square again, or rotating 1/4 of a turn. And it doesn't matter, by the way, if you go clockwise or counterclockwise. It's definitely 1/4 of a turn that creates the square. So this would be 360 divided by 4, which in this case is 90. Again, looking at the next shape, you can probably guess what's going to happen. But if I took this pentagon and I technically rotated it 1/5 of a circle, 1/5 of a turn, 1/5 of all the way around, I would wind up with a pentagon again. So that is actually 360 divided by 5, or 72 degrees. And the last one, a hexagon, again, if I did 1/6 of a turn, 1/6 of a turn, I would wind up back to the original. So this is 360 divided by 6, or 60-degree rotational symmetry. So kind of something interesting. Please make sure you write this formula down on the bottom of the page. This. Regular polygons, those with all congruent sides and equal angles, always have rotational symmetry, and it's 360 divided by n, where n is the number of sides. So I'll pause for a second while you copy that. Okay, now we're going to move on to the next thing. The next thing talks about point symmetry. And basically, point symmetry is when you rotate a figure around and it creates the same exact picture before you get all the way around to 360 degrees. Now think about that for a second. We're going to zoom in on this part of the picture. If I was to rotate this, in this case 180 degrees, I have the same exact picture. So this is what we call having point symmetry, and that is point symmetry through the origin. So this next thing, it says, which of the objects below have point symmetry? If I looked at them collectively and I rotated it either 180 degrees or even some point, right now this rhombus is looking good, the star is looking good, that parallelogram is not. If I rotated it some more, definitely the star and the rhombus are looking good, and now the playing card is also good because it looks like a king again. Again, it looks exactly like it was originally. And if I rotated it back to where I started, I would definitely say that this shape does not have point symmetry, this first one. The second one does. The third and the fourth all do. So point symmetry is when you can rotate an object all the way around and get the same object before you get to 360 degrees. Let's take a look at this next thing, which is super important. Please make sure you write. It looks like this. Which of the letters in the alphabet have line, point, or rotational symmetry? This is not in your packet, so I need you to write it down. And we're going to take each of the letters in the alphabet, and we're going to go into one of these categories. So it's either going to have line symmetry, or it's going to have point symmetry, or it's going to have neither. So each of these letters has to fall into one of these three categories. I'm going to do one of each for you. When I take a look at the letter A, it definitely has line symmetry because I can cut the letter right in half vertically. Another example, different example, for neither would be the letter G, so that does not have any kind of symmetry. I can't cut it in half vertically or horizontally, and I certainly can't even rotate it around to get it to be a G before I get all the way around. So in this case, that would have neither. And then another one that actually has point symmetry and rotational symmetry, and it even has line symmetry, is the letter H. So I would take this letter H. It would definitely have point and rotational symmetry. And technically, I could also put it in the line symmetry category because it has both horizontal and vertical line symmetry. What I'd like you to do is finish these letters, please. So you're going to go through all the letters and put them into one of these categories. So some of them will go into both the line symmetry and the point symmetry categories. Others will just go in line, others will just go in point, and some will go into neither. So finish that for homework, please. Thanks, and I'll see you later.